let the vector field v equal angle bracket a fraction of x divided by z, end fraction, comma, a fraction of y divided by z, end fraction, comma 0, end angle bracket, be the velocity field of a fluid. Let C be the solid cube given by 1 is less than or equal to x is less than or equal to 4, and 2 is less than or equal to y is less than or equal to 5, and 1 is less than or equal to z is less than or equal to 4, and let S be the boundary of this cube. Find the flow rate of the fluid across S. Let's apply the divergence theorem so that as we find the velocity or the flow rate of the fluid across S, we're going to take the double integral. Well, ultimately, we want to find the double integral on the surface S of the vector v dotted with ds. But the divergence theorem says that will be equal to the triple integral on the solid E that is contained by S of the divergence of the vector field v dv. So let's go ahead and find what the divergence of v would be, taking, as we know, divergence of v is equal to px plus p sub x plus q sub y plus r sub z, and each of those partials respectively are 1 over z, the second is 1 over z, and the third is 0, so 1 over z plus 1 over z plus 0, which is equal to 2 over z. So we need to find the integral from 1 to 4 with respect to z, of the integral from 2 to 5 with respect to y, of the integral from 1 to 4 with respect to x of 2 over z. Now, because we have some independent integrals here, independent functions, I'm going to write this as this is equal to, open parentheses, integral from 1 to 4 with respect to z of the function 2 over z, end parentheses, multiplied by, open parentheses, integral from 2 to 5 with respect to y of the function 1, end parentheses, open parentheses, integral from 1 to 4 with respect to x of the function 1. Now the second two integrals that I stated have a value of 3. The first integral has a value of 18 ln, open parentheses, 4. So the end value of this that first one is, so the second two integrals have a value of 3 and 3 respectively. The first is 2 ln of 4. So 18 ln of 4 is our flow rate. Now, it's actually written in the textbook, OpenStax Calculus Volume 3, that this is also, in fact, equal to 9 natural log of 16. I would prefer 18 natural log of 4, but just to show that those do match, those are equivalent answers.